Okay, in the first part of the lesson today, we'll quickly have a look at tangent, okay, or as you'd be well used to seeing, tan. So it's very important to understand what the meaning of tangent actually is. To understand how and why it behaves the way it does, you need to really get it, okay, because it's an unusual function and has really unusual behavior. Sine and cosine have very predictable behavior, but tangent is, well, predictable, but can be very erratic, okay. So what is the tangent? Well, if you imagine the unit circle, what I want you to do is just imagine a line drawn at the tangent at x is equal to 1. And that's on the screen now. So there we go, we've got the unit circle measured in degrees here, and what we've got is this line here. Okay, so this line here is called, or we're going to call this the tangent. Okay, not a tangent, or it is a tangent, but in relation to the tan function, it is the tangent. Okay, and what the value of tangent is basically is where a line drawn from the origin would hit the tangent. Okay, and a really good one to think about is the line that goes 45 degrees. Okay, so what I'm going to do is just draw one that runs through 45, and you'll note that the value of the tangent there, okay, is equal to 1. Right, so the tan of 45, that's my proposition for you. Okay, the tan of 45, just select this, the tan of 45 degrees is equal to 1. Okay, and we would have seen that already, because if we talk about linear functions, okay, a linear function y equals x has a gradient m equals 1. Okay, the gradient equals 1 for this linear function. And recall that we had this formula, m equals tan theta, and our gradient is 1, m equals tan tan theta, so 1 equals tan theta, and then tan inverse of 1 equals theta, and in that case theta would equal 45 degrees. It's a 45-degree angle. Okay. Now the other way we could work this out was to look at what my values were. Okay, so if I was considering looking at sine and cosine, I could do it that way. So what I would do is note that this side here is the opposite and this side here is the adjacent. Okay, so what we've got here, we can see we've got a height of 1, okay, and we've got a length here, or a base of 1. So it's opposite over adjacent, 1 over 1, it's equal to 1. All right. Let's have a look at, or go back to the notes here and have a look at, not that one, that one. So in the case of circular functions, if a tangent to the unit circle is drawn at A, then the y-coordinate of C, the point of intersection of the extension of OP, and the tangent is called tangent theta, tan theta. Okay, now that's a lot of words there, okay, but that's essentially what they're saying is we draw a line tangent to point A, okay, and where a line draws, hits the tangent, is the value of the tangent. Okay, now that also can be thought of, note, and this is really important that you note this, that that angle there, or the value of tangent, would also be given to us by doing opposite over adjacent, which is sine over cos. Okay, sine over cosine will give it to us, because that triangle there, this one here that I'm going to draw, and this bigger one here, okay, they're called similar triangles, and so the angle is the same for both of them, and so the side lengths, girls, will be in proportion to each other. Okay, so what we know is that tan over 1 is equal to sine over cosine. Okay, so we've got tan over 1, opposite over adjacent, tan over 1 is going to be the same as sine over cosine, opposite over adjacent, and therefore tan of theta is equal to sine on cosine. That's really important to know that. Okay, that identity will come in very handy. Okay, so evaluate using a calculator. So what we want to get is the tan of 1.3, and I'm presuming that this is 1.3 radians. Okay, all right, well, what is 1 radian? 1 radian is roughly 57 degrees. Okay, so 1.3 is going to be about 60, 65. Okay, so let's actually have a look at what it might be over on this. So maybe about 65, and you can see here that where it's going to hit the tangent is up high. right, somewhere up here. So if I was to draw a line through there, through roughly 65, it's going to hit the tangent at maybe, I don't know, as a rough guess, like 1.82, around about that mark there. Right, this one says to use your calculator, so we're going to go and try this out on our calculator. So I'm going to go the tan of 1.3. All right, let's evaluate that and note that I didn't get anything remotely close to 2. Okay, and why is that? Well, hopefully you're screaming at this YouTube clip that he's in degrees mode. Okay, so let's drop that into 1.3 radians. And we got 3.6. All right, so like that's a fair way off too. But what we'll learn and what we'll start to understand is that tan actually is very hard to predict for values above, say, about 50 degrees. I find it very hard to predict what tan will be. All right, so this one here is the tan is approximately 3.6 to 1 decimal place, or 3.6 dot dot dot. Okay, this one here, the tan of 59 degrees. Okay, so that's roughly 60 degrees. So again, I think that will be closer to 2. Let's try it out. So we'll go tan of 59. Come on. Okay, and ooh, I got negative. Why is that? Well, again, hopefully you understand that the calculator needs to be in degrees mode because we're doing a calculation based on a degree measurement. And there it is, it's roughly 1.6 dot 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 dot. Okay, find tan theta if theta equals 720. Okay, so there's 0, there's 360, there's 720. Okay, so a line is drawn through there and hits the tangent at 0. Okay, so let's just try that one. The tan of 0 radians would be 0. With a little practice, both sine and cosine ratios can be quite easy to approximate. The tangent ratio is a little bit more challenging, particularly as the angle approaches 90 or 270. All right, now let's try to consider why that occurs. Okay, so I'm just going to go back to my unit circle. And if I approach 90 from the left-hand side, okay, so I'm going to swing in from to 90. Actually, let's go from the right-hand side. You'll notice that when I approach 90, this line here is going to extend upwards until it hits the tangent, okay? And it's going to hit the tangent like miles above there. If you imagine it, I have to scroll up about 700 pages until I get to the point where this line would hit the tangent, okay? So let's just quickly try it out and see on our calculator what the tan of, say, 89 is, okay? And it's going to be fairly large. So it's 57. So it's basically saying if you draw an 89 degree angle, so that angle there is 89 degrees, it's going to hit this line here, the tangent, at 57. And it's crazy, but really small increments here have a massive impact on where it's going to hit it. So I'm going to go up just 0.1 and note that we've jumped 6 at 0.2. Okay, and we've jumped, well, what's that, about 8. All right, let's go to 0.4, and this should do a big jump now, 95. Let's do to 6, 143. And what hopefully you can see here is the closer and closer I get to 90, the closer I'm going to get to actually positive infinity. Okay, so let's go 89.999, and tangent is just massive because you imagine a line drawn at 89.9999 degrees. Where would it hit the tangent? It's going to be like way up there. Now, the tan of 90, well, what happens there? So what you might think is, well, how's it going to hit the tangent? How is a line drawn through 90 degrees going to hit the tangent? Let's see what the calculator says. It's undefined, and the calculator is basically saying it's not going to hit the tangent. So tan is not, you can't evaluate tan at 90 degrees. It just doesn't work. Right, now, there's really interesting behaviour then after 90. So let's go tan of 90.1 and see if you can see whether you understand what's going to happen here. So the line would be drawn, where is my line tool? Okay, my line's going to be drawn there. Now, where is it going to hit the tangent? Now, some people will say, oh, it's not going to hit the tangent. Well, not really. So the line would be drawn extending to positive, the positive values of y. But if I scroll down this page, that line would also extend down this way. Okay, so that would be that line there. Okay, and it actually will hit the tangent, but where it's going to hit the tangent is down low somewhere. Okay, it's going to hit the tangent at a really big negative number. Okay, so let's find out. So this is going to be negative, and it's going to be like negative 57 or something like that. Let's just see. Negative 572. I was out by a bit there. Yeah, and what it will do as it gets closer and closer to 90 degrees, 0.01, it's going to get more and more negative. That's not a proper maths word there, but it's just going to hit at a lower negative value, lower and lower and lower, okay? So tan's behavior around 90 degrees is really erratic. And if you understand, girls, over here at 270, it's going to do exactly the same thing. Tan at 270 is not defined at all, but just like a fraction over, and it's like it's going to be either positive infinity or negative infinity, okay? So like I said, tan is really, really erratic, okay? It's a lot more variable, or you get a lot of crazy things happening with tan that simply doesn't happen with sine and cosine. And just to put it into perspective, what I'll do quickly is just show you how or what that might look like as a graph. So we've got y equals sine x. I know we haven't seen why that this is the graph, but if we look at it, it'll give you some perspective. There's y equals sine x, right? So nice smooth curve there, going along nicely. All right, let's have a look at y equals cosine x. Same, okay, a little bit different, but you know, going along nicely there and producing those values. All right, let's have a look at crazy old tan. Y equals tan x, and there it is, okay? So what we see, girls, is the tan at 0 is 0, okay? It just starts increasing. It goes absolutely crazy here around 90 degrees or pi on 2, okay? And we'll get go to the positive infinity, okay? And then it hits the asymptote, which says it's not defined, and then we'll go to negative infinity. So it really flits around, okay? It is periodic, just like these other trigonometric functions, but it's just a little bit more crazy. So that's good old tan, okay? So X14C is what I want you to work on to just experiment around with tan a bit.